Okay, calculus, let's get our homework done. The first step, number one, we're going to write the equation of the tangent line that goes through this function, 0.2x to the fourth at 3. The first step is to find the y value. Okay, so the first step, we want to find y. So we are going to use the original function. We want f of 3. Plug in our given x value into the function. I would use your calculator table. When you input 3, you get 0.2 times 3 to the fourth, and that gives you a y value of 16.2. So now our x is 3, and our y value is 16.2. So we have an x and a y. The second step is to find m, the slope. You need to use the derivative. The derivative is the same as the slope, specifically the slope of the tangent line. So we need f prime of 3. All right, so the first thing we do is find the derivative. Using the power rule, the derivative is 0.8 x to the third. So we plug in 0.8 times 3 to the third. And that gives us a slope of 21.6. There's some fun numbers. So now we use these three items to write our equation. For point slope form, we take y minus the y coordinate, so that goes right there. So y minus 16.2, and then it's equal to our slope. That comes right after the equal sign, 21.6, parentheses, x minus, and we plug in our x coordinate right there, x minus 3. So there is your equation in point slope form. Now, if you want to check your work, solve that for y and put it in slope-intercept form. When we do that, the first thing we would do is we would distribute the 21.6, and then we would add 16.2 to both sides. So slope-intercept form is going to be y is equal to 21.6x minus 48.6. All right, so there is our line in slope-intercept form. Now, to check your work, we're going to go over here. I have 3 screenshots for you. To check your work, in y1 you put the original function f of x. In y2 you put what you think is the tangent line. I changed my window to see it. I know my y-intercept is way down here at negative 48.6, so I went way down on my y minimum. And then I graphed it, and you can see here's my tangent line, and it hits my curve in one place right at 3. Okay, to write a differential, we need to find and get dy all by itself. We don't have any differentials, so to get differentials to appear, we take the derivative of both sides. All right, so the derivative of y, we use Leibniz notation, and that becomes dy dx, and poof, we have differentials. To take the derivative of this, that is a power rule, so that becomes 21x squared. Now, in order to get dy all by itself, we need to get rid of dx. Since dx is in the denominator, I simply multiply both sides by dx. All right, these are going to cancel out. dy is all by itself on the left. That was my goal, and it's equal to 21x squared dx. That is what we mean by a differential. Okay, so the shortcut is, hey, y becomes dy. You take the derivative of your function, and you toss dx on the end. That's the shortcut. Number 3, let's use the shortcut. Y becomes dy. We take the derivative. This is going to be a chain rule. The outer function is something to the 7th, so the derivative of the outer is 7 times something to the 6th. The inner as is x to the 4th plus 1, and the derivative of the inner is 4x to the 3rd. So we're going to simplify that. dy is equal to, I'm going to multiply the 7 and the 4. That's going to give me 28. Might as well put the x cubed right with it. And then x to the 4th plus 1 to the 6th, and I toss dx on the end. There is my differential. Done. Number 4, y becomes dy. These are 3 power rules. The derivative of 3x squared is 6x. The derivative of 5x is plus 5. And the derivative of negative 9 is 0. And I simply toss dx on the end. So the shortcut, y becomes dy. You take the derivative and toss dx on the end. That's what a differential is. Number 5, y becomes dy. This is going to be a chain rule, so e is the outer function, so the derivative of the outer is e to something. The inner as is negative 1.7x, and the derivative of the inner, I'm just going to put it out in front, negative 1.7. So there's my derivative, and I toss dx on the end. Differential done. Number 6, again the shortcut, y becomes dy. To take the derivative of this, that's going to be a chain rule. The derivative of the outside function sine is cosine. The inner as is 3x, and the derivative of the inner is 3. I'm going to put that out front. So I need dx on the end. That's my differential. Number 7, the first thing that I would do is I would rewrite this. Okay, this 3 applies to everything immediately to the left and to the right of it. So get rid of that weird trig notation. That's equal to the tangent of x to the third. Okay, so to take the differential, y becomes dy. To take the derivative of this, that's a chain rule. The derivative of the outer is 3 times something to the second. The inner as is tangent of x. And the derivative of the inner is secant squared of x. And then I toss dx on the end. There's my differential. All right, y becomes dy. I took the derivative, I toss dx on the end. Number 8, y becomes dy, easy first step. All right, to take the derivative of this function, there's 2 functions multiplied together. That is going to be a product rule, 1d2 plus 2d1. So 1 as is 4x. The derivative of the second function, cosine, is negative sine of x. So there's my 1d2. Now I come back with the second function as is, which is the cosine of x, and I multiply it by the derivative of the first function, 4. So that is 2 as is, and that is the derivative of the first function. And I don't forget, I toss dx on the end. Now absolutely, I'm going to simplify this thing. All right, I can factor. All right, so remember, think of that as one big binomial. This term plus this term. All right, so what's common to each side? Well, I can factor out a 4. Not much, but I can put that 4 out in front. So it looks like this, 4. All right, when I divide this term by 4, I'm left with negative x sine of x. The plus comes down. When I divide this term by 4, I'm left with the cosine of x. And then I toss my dx there. There is my differential. Okay, for number 9, in order to take the derivative of these 3 terms, especially the first 2, I don't want to use the quotient rule, so I can rewrite this. That's the same as 1x squared over 2. I can rewrite it as 1/2 x squared. Now I can use the power rule. The second term, that's the same as 1x over 4. I can rewrite it as 1/4 x. So first, rewrite it to avoid the quotient rule, so we can use power rules. Now to take the differential, y becomes dy. I use the power rule on all 3 terms. The derivative of 1/2 x squared is simply x, because 2 times 1/2 is 1, and 2 minus 1 is 1. The derivative of negative 1/4 x is minus 1/4, and the derivative of plus 2 is 0. So there's my derivative, and don't forget, toss dx on the end. There's my differential. Number 10, y becomes dy. This is going to be a chain rule. Cosine is my outer function. ln x is my inner function. So the derivative of the outer function is negative sine. The inner as is ln x. and the derivative of the inner is 1 over x, and then I toss dx on the end. I could write that as one fraction. I can put negative sine ln x on the top and x on the bottom. Either or is acceptable. Okay, for the last three, we're going to take the antiderivative. So we have to undo our differential. So dy is going to become y. To undo the power rule, I'm going backwards. I have to add 1 to my exponent. So that's going to become something x to the 4th. All right, and then I ask myself, 4 times what will give me 20? And that has to be a 5. And on the end of every antiderivative is plus c. There we go, undoing the power rule. Number 12, we have to undo the chain rule. So that's tricky. Ask yourself, hey, what do you think the outer function is? Well, this looks like the derivative of the outer. So what function do I take the derivative of and get cosine? Well, that has to be sine. All right, so I think sine is my outer function. This right here looks like the inner as is. All right, so that's what I think my antiderivative is. So let's go off to the side and check. To check an antiderivative, we simply take the derivative. All right, so the derivative of sine is cosine. The inner as is 4x, and the derivative of the inner is 4. So this right here gives me this, 4 cosine 4 of x, but I need a 1 out front. So what can I put in front to make that 4 disappear? I can put a 1/4 there. Now when I bring the 1/4 along for the ride, hey, excuse me, that's supposed to be a 4. This cancels out and I'm left with what I need. So to take the differential, or to undo it, to take the antiderivative, dy goes back to y. My antiderivative is 1/4 sine of 4x, and don't forget plus c on the end. Antiderivative, we undid the chain rule. And finally, number 13, hopefully you recognize this. This is your derivative flashcards. So what function do you take the derivative of and get secant squared? Hopefully you said tangent. So to take the antiderivative, dy goes back to y. The antiderivative of secant squared is tangent of x. Toss plus c on the end. Thanks, calculus. We will use this when we learn u substitution to take the antiderivative of the more complicated functions.